Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to talk about a big, exciting new feature that we just announced at last week's epic Spring I/O conference in Barcelona, Spain. This feature is really just a formalization of support that's already been there in some form or another across a number of different projects. That is to say, reactive transactions. So we have two interesting projects that support transactions at the moment in the reactive space. We have MongoDB, which as of 4.0 now supports transactions across discrete documents. And we have R2DBC, which is a reactive SPI and a number of different implementations based on that SPI for talking to SQL data stores. And both of these are reactive from the ground up. They support asynchronous I/O from the ground up, and they offer support for transactions. So here is an opportunity for an abstraction. So while there is already individual support in MongoDB, in the Spring Data MongoDB project and in the R2DBC projects for transactions, there has not been some sort of common standardized integration for both of them, just like there is right now for Spring's Platform Transaction Manager hierarchy. So what we're going to talk about is that new support. We're going to look at it in both MongoDB and in R2DBC with a trivial example, which of course I'll build here at start.spring.io. So I'm going to go ahead and build a new application. I'm going to call this RxTX. We'll use reactive MongoDB. We use Lombok. We're going to use the, let's just use reactive web. I'll actually just get rid of that later, but we'll keep that there. And I think that's probably all that we need for now. I'll bring in 2.2.0 M3 of Spring Boot. Open this. Downloads. UAO rxtx.zip. This will spin up, and of course, first thing we're going to do, we're going to use MongoDB first. We'll do this in MongoDB terms first, and I have MongoDB running on my local machine. Now, keep in mind, you can't just use regular, like if you just did brew install MongoDB, the resulting installation wouldn't work, and the reason is because you have to have a replica set. And so I have this goofy script that I use that maybe you might want to use as well, just to get a local replica set going. So there's that script, right? So it's just, I'm creating a data directory, make the data directory, and then I do MongoDB replica set equals my replica set, db path, data, blah, 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 background that, and then I evaluate replica set that initiate to initiate the replica set. So that's the stuff I have to do to get a MongoDB instance that works in a way that I can use transactions, right? Just as I understand it, MongoDB 4.2 should have distributed transactions across multiple nodes, but for now this is I think it's limited to one node. I'm not, or at least to one replica set. I'm not quite sure how that works exactly, but I know you need a replica set. So we have this, and now you can use our application here, and I'm going to do the normal things here. I'll create a let's see, I think I want the font to be a little larger, don't we? So make the font, okay. Here we go, and we want those to be, let's say 24, good. And we're going to create an object to write data to the database, obviously. So class customer, and we'll have a private string ID, private string email. All right, email works. And then it'll be a document, of course. We'll have a primary key that will document, we'll map using the ID annotation at data at all_args constructor at no_args constructor, right? So just the normal stuff. And I'm going to create a repository to persist and manage instances of this entity, of course, using the reactive CRUD repository. Managing entities of type customer, whose primary key is of type string. And then finally, I want to use this. So I'm going to create a test, right? But in order for this to work, I need a few things in order to benefit from Spring's transaction support. So the basis transaction operator here, in order for this to work, I need to create a few things here. So transactional operator dot create, passing in a reactive transaction manager, and the transaction manager implementation, of course, varies from one persistence technology to another. So we're going to use a Mongo transaction manager. Okay. So we say new Mongo transaction Mongo here. Best way to do it. Reactive Mongo transaction manager. Okay. And that's an implementation of this common type called Reactive Transaction Manager. It in turn expects a reactive Mongo database factory. So reactive Mongo database factory. Alrighty. And then DBF. Good stuff. So there's that. Now that should be enough for now. Let's go to our test code, and actually we'll just try this out. We're going to create a service, right, to handle this transactional logic. So we've got a repository. A repository is good for boilerplate sort of, CRUD style stuff. Create, read, update, delete. The boring lifecycle management of data. Okay, very simple stuff. Now we're going to create a customer service, and we're going to have a method here that returns saved customers that it's going to write in bulk based on their emails. Okay, so very simple thing, and I'm going to implement this as a thing that requires multiple writes. Now there are better ways to do this, but I want to have multiple independent discrete writes. So what I'll do is I'll say let's create a publisher out of the emails rather. I'm going to take each email and turn it into a new customer. Okay. I'm going to take each one of those customers and write it to the database. In order to do that, of course, I need to inject my repository here. So customer repository. And we'll make this a service. We'll tell Lombok to synthesize a constructor. So it'll create a constructor, and for any field that's final, it'll create a parameter and some storage for that. So we'll do that. And then customer repository.save customer. All right. Now there's our whole pipeline. So there's my data. And now what I'm going to do is I'm going to use, we're going to look at three different layers, three different approaches to transaction management. Okay, so the first one will be I think the most flexible. So this dot, we need a transactional operator. So private transactional operator. All right. And this is sort of like the transaction template, right? You can just provide a new transaction callback, right? And you provide a publisher that's returning something in the transaction. And in this case, I can just return this, right? Remember, we're not executing anything yet, right? We're not actually executing we've created a cold pipeline, right? A cold stream of data. There's no actual data flowing through this. And so even though we defined the transaction outside of the, or rather we define the logic that has transaction, semantics, we define that outside of the transaction block. It doesn't matter because we're not executing it. It only gets subscribed to in the context of the transaction. And of course, this is well suited for Lambda. So that's very simple. And return that. Okay. And this transaction template is nice because you can actually, it is just returning the exact same thing that we gave it. It's returning us a publisher of customer. So I could then compose that with other streams. I could continue processing it, but only the stuff inside of that transaction operator .execute block would be executed inside in the body of a transaction. So now we've got this. Let's create a simple test. To test things out here. Okay. And this will be a public class at run with spring runner dot class spring boot test, and we're just gonna create a test script basically. Okay, so test public void save all. Okay, throws. There we go. And we're going to inject our transactional operator. Alrighty. And actually, no, we're going to inject our customer service here. So we'll say customer service. And all I'm going to do is I'm going to write some data to the database. Now, I didn't actually define what will fail. So this is a happy path kind of thing. I'm not doing any validation on this. Let's say that I go through each customer in the publisher, and I decide that, oh well, one of these has an invalid email. Well, I can't persist that, so I'm going to do a do on next. I'm going to say, okay, we're going to assert that the customer.getEmail.contains at, right? If it doesn't contain that, then it'll throw an exception, and the transactional operator will see that, and it'll roll back the transaction. It'll emit an error, basically, and that'll roll back the transaction. So the email must contain. Okay, there's our updated code. So now I'm going to test that script out. What I'm going to do is I'm going to write some data to the database. So I'm going to say, well, first of all, we're going to delete everything in the database. So we'll say create this.customerservice. We're going to use the repository to do that. So what I'm doing is I'm using the reactive, the reactor step verifier, of course, to make short work of running this test that has reactive dependencies here. So I'm saying customer repository.delete all, and then I'll expect it to be complete. Right? I think that works. So let's try this. That should work. So I'm resetting the database. There should be nothing in the database at this point. Okay, good. Now let's write some more data. So we're going to say this.customer repository dot we want to do the insert, don't we? We want to say this.customer service.save all will be a at a.com, b at b.com, c at c.com, and d at d.com. So we're expecting there to be 4 records in the database now. So expect next count will be 4, and we should have 4 results from the save operation there. Those are all valid emails. Great. What about let's do a query to find everything in the database to confirm as much. So I'll say .create this.customer service .repository .find all. Expect next count will be equal to 4. Okay. There's that. And then finally, let's write 2 bad records to the database and confirm that after we've written that it's going to we should see it roll back, and so we should see that the total number of records in the database is still 4. Okay. So let's try that again. Save all. 1 and 2. Expect error. Verify. So we're expecting that this should result in an error, and we're expecting that neither record, even not the first one, not the second one, will have been written. So here, well, actually we can try one. We'll try a at b.com. There you go. So that's or better yet, e at e.com. Okay. So we should see one of them not written. So we should see that they're both rolled back, even though one was valid. Okay, because there's an exception. So now we're going to say this dot customer service dot repository dot find all dot expect next count here, and that should be equal to 4 still. Okay. So let's see what happens if we run this. Okay, what did we do wrong? Oh, right. Expect next count 1, sure. Try that again. Okay, so we can see that even though we got 2 records back, we got 1 regular record and 1 error, that when we did a query of the database, we only had 4 records in the database still. And that's to say that these 2 were rolled back. They were in the same transaction, the same logical transaction. And so we can see that we're using the transactional operator to do that right, and to enclose all of this logic in one logical transaction. Now this is one way to use transactions in Spring. It is very low level, but it's nice because you can give it any publisher and it'll enclose that publisher in a transaction. It's, like I said, it's very akin to the transaction template in Spring Framework. And this, of course, does live in Spring Framework. You can see this is actually part of Spring Framework's transaction support. It's under the package Reactive. Okay, so that's one way to do it. The other way to do it is actually to say that we're going to do this as this.transactional operator .transactional, like that, and so you just return customer flux. Okay, so here we're actually using the transactional operator again, but we're actually adding it to the end of an existing pipeline rather than wrapping it. The effect should be the same. Let's run our test and see what happens. Okay, there's our test. Good, that worked just fine. And now the other way we can do this is we can use declarative transaction management. Okay, and so the way that works is you say @enable transaction management, and here, just like in Spring, just like in regular synchronous blocking transactions, you can just say @transactional and just return that. So we don't need this anymore. All right. Yeah, not bad, huh? So, 3 different ways to use the transaction management support here. We've done this for MongoDB. Now, let's try R2DBC. Okay, so with R2DBC, not a lot has to change. Obviously, they're not the same kind of data store. One's a document database, one's a SQL data store. So I'm going to use Postgres. I'm going to turn this object into a thing that has a monotonically incrementing primary key. Get rid of the document annotation. I'll go back to my build here. And I'm going to replace some of the dependencies, namely the MongoDB support, with the equivalent and new support for transaction management. So get rid of that, and we want a new experimental dependency. So I need to actually, this is not actually part of the Spring Boot or Spring Data release trains, and so I need to bring in this custom thing here. Dependency management, dependencies, dependency, Spring Boot dependencies R2DBC, and this is 0.1.0.m1, and it'll be type pom scope import. All right. So there's that, and with that in place, we can now bring in the equivalent, the appropriate dependencies for R2DBC itself. This including this new experimental, but very interesting and very promising auto configuration for R2DBC. Right, this is new as well. So Spring Boot starter data R2DBC. Yes. Okay, bring that in. And that in turn, we can also bring in the Spring Boot starter for just R2DBC without Spring data. So if you don't want the repository support, then you don't need to bring it in. You can just bring in the DBC, the database client and stuff like that. But okay, either way, these are both here. We want to use Postgres, not MongoDB. So I've got Postgres. Okay, so no, we want the R2DBC driver, don't we? So that would be IO R2DBC. Okay. And we want the connection pool support. Alright, good stuff. Now, let's see, what else has to change? Well, I think that'll work, actually. I think that's pretty much it. What am I missing? Gotta change this, of course. So this is the R2DBC transaction manager, and it expects a pointer to the connection factory. And the connection factory, of course, is the thing that we use to describe our connection to the database, our SQL database. And we're going to be using a connection factory here. Postgres connection factory. And in order to get that connection factory, I'll inject the URL using a property placeholder. We'll come back to that in a second. So spring.r2dbc.url connection factories .get URL. Alright, so there's that. And now, of course, we need the property itself. We'll configure that now. Equals. And then that is the JDBC URL for my database, which, give me a second. Alright, this is R2DBC, that's the new protocol prefix, colon, PostgreSQL, colon / orders at localhost 5432 / orders. Okay, so that's my database running on my local machine here. Let's try that same test again. Cool. So there's the same test again, written again with the new code, and you can see that we were able to, get the same results, right? We saw the same behavior. Orders. Select all from customer. There's that, right? We saw 4 records, and if we go here to MongoDB, it'll be db.customer.find. There's our 4 records. Alrighty, my friends. I hope you got something out of this. I hope you'll give out the new give the new transaction support a try. Obviously, there's a lot of interesting opportunities here with more and more databases coming online as being supported and having reactive integrations. This support, I think, means that now a whole class of workloads that we thought sort of unobtainable in the reactive world are now available. So that's exciting. Thanks so much for watching, and as always, we'll see you next time.